Hello everyone and welcome to EG Jewel Lapidary. My name is Eli Ganeem and today we're going to talk about uh, measurement, and we're going to use a lot of you. We have the Vernier Caliper to check and measure with, and so today I'm going to show you a lot of different ones that I have, but they're all the same basics. So we're going to talk about metric dimensions and also the inches dimensions. So stick around and don't go away. I'll be back in a second. Okay, here we have, I got about 7 different ones here that we're going to go through very quickly, and just to show you what I have. So the first one, this one here, is basically Vernier Caliper, and it's plastic. It's made in Taiwan. It's kind of cheap material, cheap vernier, but I don't use it much. The reason that it's plastic, like if you're doing any faceting, they're saying, okay, you can put your facet in, you measure so it doesn't damage, but I don't use it. When I do faceting, I use the regular one. So if you don't use it as a vice grip, then that will work for you. Okay, the other one that I have, this one here, it's also in millimeters, but this is a dial caliper. So a dial caliper, where when you move or trying to measure anything, you have the dial here that's going to be giving you the dimension that you want. That's a dial, but this here is metric only. Now, this one here is the Mitutoyo caliper and vernier, and also it has only inches. So this one here is only inches. Then I have this one here, which also Mitutoyo, but it has both. It has metric at the bottom and inches on the top. So you could use both of them. Then there's another dial caliper, which it has the dial indicator, and this is only inches. This is made in China. So when you turn it, and every time you get the dimension, you can read it from the indicator. You get the points here and then the indicator there. So that's another one. Then we have the digital caliper. So the digital caliper is basically, this one has metric and inches also, and when you put it on, it goes, you could actually change it from metric to inches anytime you want, and then but we're going to go through how you use it later on. This is another one also, digital caliper, that's from Mitutoyo. As you can see here, there is no numbers or inches or metric. However, this one also, it will change from inches to metric by pushing the button here. Now the other one that I showed you before, this one here has the numbers, metric and inches on it. This one has nothing really, but it acts the same because you're not using these numbers, you're just using, or the readout, so you can read the dimension that you have. But then we're going to go through that also, all of them. Now, this one here, I'm just going to put aside because we're not going to talk about this one here. the dial, if I look at this dial, which is metric, most of the tools, even though this one is plastic and I really don't use, which is going to explain to you because this is in metric, all of them, they actually show you what the dimension or how you read them, or the every segment or every line, how you can count it. So first, actually, before we go into this, let me show you how you can use the verniers. First, like how can you measure? What do you use it for? So I'm going to take one. Let's say this here. It's a simple one. So now we know that here where you can measure everything. So you go in and you measure anything. So I have this one here. I'm going to go in and I'm going to measure it that way, and I get my reading out, which is fine. But then you have more than just this. For instance, what is this for? This one here is to basically measure the inside diameter of something. So if I have this one here, I got a hole in the center. I can go in and I just fit it right inside and find exactly what the diameter is. So this is to check the diameters, inside diameter. Okay. Now, so we have this one here, check outside dimension, this inside diameter, but also we have this here. So we're saying what we call a detail that comes out. Well, what do we use it for? Let's see. When it's set flat here, that's set to 0. So if I want to check the depth here, what I'm going to do is I'm just going to go from this point and I'm just going to set it up right here and go in like that. Okay, so then I can get the depth dimension it's giving here. If you notice right here, there is a little relief at the bottom here, right there. So there is a relief, and that relief is sometimes if you have something here at the bottom or at the corner where you're checking, you could just put it up that way. So this way you can measure without hitting any chamfer at the bottom, or so you go like this and here you are. So you can measure this way. So now we have this one here, inside diameter, depth of something. So you could also use this one, especially if you have something that is closed. You can always go from the top and measure the depth up. Okay, so I can go like this and I can measure the depth and I know exactly the thickness of this piece. So if you have, let's say, I don't have anything here, but I thought I did. So okay, so let's say this here, no, that won't fit. Okay, let me get something else for you. Hold on a second. Okay, so let's say if I need to know the depth of this bottle, all I have to do is to go on the side, make sure that it's straight, and go all the way down and check the depth. Dimension is right here, so I can see it. So for any depth that you cannot reach, this one is used for, which is the tip. Now there is another one that it's right on the edge here. So if I use this one as my 0, now every time I move it, I got a dimension right there. So this is my 0, and here it gives me the dimension. So for instance, if I want to check again the depth of this, I can actually set it up right here and here. Push it in. Now I got a dimension. So same here, I can put it right there, it's at the edge, and move it in, and here I get another dimension. So we're using this one here for also the distance that is blocked. I cannot measure it this way, I cannot measure it this way. I mean, you could, but it won't be accurate. So this is not accurate. I can measure it this way, yes, but this is mainly used for depth, for holes, okay? And this here, it's used for getting these dimensions. So now we know we got 1, 2, 3, 4 different ways to use the vernier. Now all of them are about the same thing. Okay, you could use them. They all have the same thing. Okay, so if I open this one, again I get the tail, the relief down at the bottom. I get the size for the inside diameter. I get the outside dimension, and I get also the distance on the back here. Okay, so these are the different ways that we could use these calipers. Now, I don't know if you realize that I mentioned vernier and caliper. Now, they're all calipers, but the difference is this is a vernier because it has the small graduation or divisions that it gives you the fine dimension or closer dimension to what you need. So this is the vernier. This is the vernier. Now, this is the dial caliper. Okay, so dial caliper is same as this one. This is the dial caliper. So we have vernier caliper, dial caliper, and this is electronic or digital caliper. So we got three different. They're all calipers, but they're different applications. So one thing is that we need to watch out is these are expensive tools, and I'm not talking about these plastic ones. I'm talking about the Mitutoyo that I have, and they're not cheap, but also they are not a tool that I can use as a wrench or a vice grip, or when you measure something, don't push too hard on it. It's very delicate. You go in, you touch it, you're dead on, right on it. You don't need to force it in any way. So once you finish using it, make sure you put it back into their boxes. Usually they come like this one here. It will come into this box here. And just leave it in, close it, and put it aside. So this way you always have it nice and clean. The other thing is that if you drop it, you need to readjust it. This one here, it has a zero adjustment, but doesn't mean that when you have a zero adjustment here, that's going to fix everything, because if you hit it down here, do you know if it is correct or not? Correct. Now, I have these tools. Now, these tools, they're perfectly ground and exactly to size. Now, I have these, and not everybody has them, but if you don't, but most people has drills. So you can get a drill, and actually, let me go back. In the company, if you're working with a machining company, that they use this tool all the time, and they have to have the calibration done to these tools, and it has to be marked, dated, and signed, and that done every 6 months. Okay, that's for the ISO 9000. So you have to have this one always inspected. If if you drop it, you have to take it back and it has to be re-inspected again. But for us here at home, we don't have that luxury to give it to your inspection department so they can check it and make sure that it's correct. So what we're doing is, here I'm using these tools. And actually, I wasn't going to talk about this, but there's John Daniel. He mentioned that on Facebook, and I figured, okay, I gotta show you guys. He mentioned about gauge block. Now, the inspection department, they usually have a gauge blocks, but he said, well, if you don't have a gauge blocks, which is a good idea, you could use tools like this. And if you don't have these, you could use a drill. But don't take any drill that's been used and it's all marked up on the outside. Get a new drill. You know the size of it, and you go in and you just measure and you see exactly where you're at. So that's a way where you can actually adjust your calipers. Now, let's go about the I'm trying to make it in sequence that you could understand, or you'll be able to learn with me all the things that I have. So I'm going to leave the digital one till the end because this is the easiest one. And if you can get a digital caliper, that would be great for you. I mean, it's easier to see the dimensions right away. So right now I'm going to go and I'm going to talk about the millimeters, which with the tutorial right here. So let's leave this aside. And if you look here, you could see, I'm going to get a closer look at this one in a little while, but the dimension, and I'm talking about metric now, this one has both metric and inches. So if we're looking at the metric dimensions, you could see the numbers on the top here, and these are, each one is 10 millimeters. So this is 10 millimeters, 20, 30, 40, 50, and so forth, millimeters. Within the millimeter, 10 millimeters, there is the 10 millimeters inside. There is another line down here in the middle, which is 5 millimeters. It's a little bit longer, so it shows you that halfway of the 10 millimeters. And I think, let me show you this one here on a bigger, okay, now you could see it. So, like I was saying, that you get, this is 10 millimeters. The longer line here, which is 5 millimeters, 10, 15, 20, 25, 30 millimeters. Then we could see all these lines down here, which is also graduated, and it has up to 10. So what we did here, now what's good about metric is everything is divided by 10. So now this from 0 to 10 is a division of 1 millimeter. So every millimeter is divided here into 10. But then you're going to say, like, how come this is big than that? And you're just talking about this is 1/10 of a millimeter, like just smaller decimal. I'll show you why. So let's say here, we have a dimension here that is 10 millimeters something. And if I look at this 1 millimeter, the zero line, it's basically in the middle of it. Not quite, but basically in the middle of it. So that means that 10 millimeter 0.5. So if I go here, this is my 5. But I know, now I'm going to zoom on this one here. But if I look at the lines here, they don't match. The one on the top and the one on the bottom, where the 5 is, does not match. The 5 is towards the right. Then I go to the 6. If I look at the 6, does not match with the top line here either. It's further down to the left. That tells me that between the 5 and the 6, right here, there is something else that match these lines. And if I look at it, I will see that this one here will match more than the other two. But if I look at this one here, between the 5 and the 6 is divided into 1, 2, 3, 4, 5 division. Each one is 2. Get that? So this is 10. So each one is 2. So if I'm here 5, which is half. So let's go back to this. 10 millimeter, 0.5. Back to here. 0.5. And I figured that this it's closer. Okay. So I will take 0.5 to 4. Okay, so that's 0.54. Okay, let's take another example. Here's another example. Again, we're about the same area here, but if I look at this, I'm a little bit even over the half of that millimeter. So I know it's after the 5. So this is 10 millimeter point. Let's go back. Here is the 5. And here is the 6. Again, the dimension is, if I look at which one is the closest, now the 6 is over this way, but if I go to the 7, it's inside. So now I get between the 5 and the 7 is this way, or if I take the 6, it's in. So I know my dimension is between the 6 and the 7, right here. So the dimension is going to be 10 millimeter, 0.6 something. So if this is 6, what is the closest number? I could see this one here or that one there. So you can decide. I mean, the difference is so minimal here that for your dimension, I will say 2, 4, 6 right here. So that's 10 millimeter, 0.66. Does that make sense? Here you go. So 10 millimeter in the front, 0.6 and 6. So this is the way actually you measure with the metric system. So that's how you use the bottom portion and you use the top portion. So going back to this, we know that everything is divided into the into 10 millimeter each number on the top here. Each 10 millimeter has the 10 divisions, with the 5 in the center is a little bit higher than the other ones. We have the 0 point, which is this one here, that if you put everything, you close the vernier, it will be at 0, lined up. And then when you go and open, then you check from that 0 point, where are you at on this millimeter. So this one here is 10 millimeter, 0.5 something, and that's the one we did the first one. So, and this is the second one. It's a little bit more than the 5, so we found out that between 6 and 7. Okay, so it's got to be somewhere around here, and sure enough it was 6.2 for another 6 or 8. You know, I mean, if you could go in, if I have this one like this, which is more in line between these two, I could say 0.67, because it's 2, 4, 6 up to this point, and if it's between these two, that will make it 7. Okay, so that's the side here. So if we're using this one here, this is my 0 point. So when I go here, it's lining up 0, and then I go in and I check any dimension I want, and breathing the smaller increment down here at the bottom, and that will show me exactly what I need. Okay, so this one here, it's a lock-in screw. So I can go and get any dimensions, lock it in position, and that's gonna hold it from moving. Just held like this, and it's gonna stay. If you need to go and measure something else, see if it's the same or not, then you'll be able to lock it in position. Okay, so that's one. The dial indicator, which is this again, because we're talking about metric, I'm going to use this plastic one. This is a dial indicator, so that's a dial caliper. Again, you could use inside diameter, the outside here, from here to there. You have also the tail measurement for inside dimensions. Now, this one here, each rotation or revolution is 10 millimeters. So if I go to 0 here, that means I got 10 millimeters. So each division in between is 1 millimeter. So this is, if I go back here, this is 1 millimeter right there. Let me show you that on a higher or bigger. Here it is. So each one, if I go like this, that's 1 millimeter. That means that, here you go again, from here to here is 1 millimeter. Okay? It's like this. That's 1 millimeter. 1 millimeter, 2 millimeter, 3, 4, 5, 6, 7, 8, 9, 10 millimeters. So again, this one here, each full revolution is, we said, is 10 millimeters. Okay? So when the dial turn around from 0 back to 0, that's exactly 10 millimeters. If let's say we're going from 0 to here, so this will be 1 millimeter point 1, 2, 3, 4, 5. That's a millimeter and a half right there. 1 millimeter and 5, 1, 2, 3, 4, 1, 2, 3, 4, 5.5 up to here, or 5.5 is on the dial. So 5.5, 6, 6.5, 7, 7.5, 8, and so forth. Keep going with that. So this is the with the dial indicator. Okay, this over here is, again, it's metric, and inches. We have the millimeter and inches buttons right here. The 0 is the setting right there. So if I push this one here, it will show me that this is millimeter. If I push it again, it will show me that this is inches. If I push this one here, it will go to 0. So it doesn't matter where I have it, I can push this one and it will go back to 0. Okay? Now, let me get you a closer look. So that's 10 millimeter, 0.37. So this is easy to do. Now, if I want to, and you could see the millimeters right on the top. If I push this one, I don't know if I have another one with the, no. Okay. What is it? Here it is. So if I push 0, it's 0, and if I go whatever size here, this is inches, so I got 11.17. If I push the millimeter into inches, it will tell me that this is 0.440 inches. So I can change between metric and inches just by pushing that button. Then I go back to 0, set it up to 0. Going back to adjusting your dimension. If you drop this one here, and I'm going to go in, I'm going to have it into inches because this is in inches, and it's 0. Then I go in and measure this one here. And that gives me 0.4, actually 0.5 right there. I'm not pressing hard on it. That's 0.5. So I know that this is 0.5. My measurement here is 0.5. So I know that this is correct. Okay. Now, the other thing I was talking about where you could actually set it up to 0 from this point. I'll show you what I'm going to do. If I set this one to 0, we know that this is ½ inch. Now it's 0. If I go and I measure that bigger one, which it is, this one was, I believe, 3/4. Yeah, that's 3/4 of an inch. So if I go back here, that is going to give me basically the difference in the diameter. 250, 249, 250, right there. Okay, so that gives me the difference between the two. Okay, let's talk about this one here again. That's in inches and also in metric. So any dimension that I take, it's a readout. I'm going to see the dimensions right on the top. So that's a lot easier to basically measure anything and get the reading out. So this one here, it's open at 30.12 millimeters. So if I press the button down here, which it will go from metric to inches, it's going to look like this. Oops, that's the wrong one. It's going to look like this. So when I push this one, it's basically 1 inch, 0.186 of an inch. So you could actually reverse between metric and inches by pressing the button. Okay? Now, these here, they actually take a battery that it will be fitted inside. And it has, this particular one has 4 bolts, 2 on this side, 2 on the other side. The top comes off and you change the battery on the inside. Again, like I said, there's no gradual line. You don't have to read anything. This is a lot simpler by just getting your any dimension, any size, and you will read it right here. The other one is the dial. Now with the dial is basically you're going to see the dimensions here, and then the decimal point is over here. Okay, so now this is the metric system. And these two, like I said, is you basically change and it goes into inches. But if we have this system here, which is, now I got this one here, it's all inches, but the lines are not as dark as this one. So I'm going to use this on the top to show you the dimensions that we're trying to calculate as inches. So if I have, let's see if I can see it back again here. Okay. Let's take this one here first. So now we have the inches are on the top. Now the inches, it's a little bit difficult. I mean, the metric, I said everything is divided by 10. Everything is by 10. The inches, it's more complex. Let me show you. So the inches is divided, 1 inch is divided into 64th, 1, 3, 5, 64th, 1/32nd, divided into 16th, and divided into 8th, 1/8. So there is a lot of divisions here that you got to go through. The most common one are the 16th and the 8th, which is 1/8. If I go 1/16, you get 3/16, 5/16, 7/16. These are more common or more used. If I go into the 1/8, you get 1/8. You have 1/4. You have 3/8, and you get 1/2 inch, and so forth. Okay. So these are the divisions here. Now, this chart you could actually download it for free from the internet. You can go in, download it, and it's pretty good because it shows you all the fractions. And with the fractions that we have, we also have the decimal point, which is right there. So if you want to calculate finer dimensions, is you're going to use the decimal point. Also, this here, this chart, it has the conversion into metric. So you can go from inches to metric. It's right there. Okay. Now, this also, it's good to know if you want to convert it yourself. 1 inch equal 25.4 millimeters. So knowing this here, you could also convert it yourself anytime. So this one here, it's a quick view of especially the fraction dimensions into decimal. You can calculate it right away. Okay, this one here. Okay, so we go back to this, and how do we measure the fractions here, or how it's divided? So 1 inch Let's go like this. Okay, so 1 inch, which is here, is divided into 100, which is 100, 200. Each number here is a 100. So you get 1 inch is 1,000. So that's 1, 2, 3, 4, 500, 600, 700, 800, 900, and 1,000. So that's the division of the inches, okay, divided to 1,000. So 1,000 of an inch. Now, if I look at the top dimensions here, is the same like we talked before about the metric down here. They look large, but actually it's not that much. So here it's one, every number or every division is 1 of 1,000. 1 of 1,000. So from here to here is 5,000, 10, 15, 20, and so forth, 25. But each division here also, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See that? And so forth. So it's all divided into 5 divisions. So if we're going to read the size that it is right now, I know that this is 400 right here, something. So 400 and what? And then you go down here and you look at the line that is matching down here. And if I go across, I could see that here we're getting closer right there, here. So this here, see that? This and this lining up. So 15, 16. Point 400, because we didn't go to the 1 inches or 2 inches, 3 inches. So still point something. So that's point 416. That's the dimension here. Half inch, which is right there, it's 0.500. So if we are, let's say we're going to fractions, which is this one here, if I take the quarter inch equal 0.25 right there. Okay, so how do I see it here? 0.250. So here between 1, 2, 3, 4, 5. These are 5. Okay, so right in the middle, each one is 25. Okay, see this one here is 25. So each one is 25. 225, 250 is going to be right there. 300. And so forth. 325, 350, 375, 400. 375 is basically 3/8. Now there is other dimensions. Okay, let me see into this one here. Now I am not sure if I have a picture of that or not. Like what I was talking about was this one is the 100s. 1, 2, 3, 4, 5, 6, 7, 8, 900, 1000. That's your 1 inch. The 1 inch is divided into 8s, 1/8, and 1/16. So this is 1/16. This is 1/8. This is 3/16, which is 1, 2, 3, 16. That's 4/16, which makes it quarter inch. 5/16, 3/8, 7/16, ½ inch. So each division here is 1/8. The longer lines, 1/8, another 8, another 8, another 8. That'll make 1, 2, 3, 4. That makes ½ inch. 8 of them makes 1 inch. Okay, so that's basically how it is divided here. And then the smaller dimension will be right, you could figure it out from the top here. But as I said, usually you're going to use this system here, or these dimensions, to figure out exactly what your dimension or the actual size of your dimensions using these here. Okay, just to summarize everything back again. So we have different calipers: Vernier Caliper, Vernier, digital, and dial indicators. So these are the one, and if you're gonna get one, you know, there is a lot of different ones, you could buy them. But whatever you do, make sure that you keep them clean. Don't use them as a vice grip, please. Make sure that they're clean when you put them away, and they will last you for all your life. So again, if you drop it or you think that the dimensions are not correct, get yourself a drill, brand new, or a tool, and go in and measure it. Make sure that it is the right dimensions. If you go down here, and another thing, what you do is when you go in, just clean it. Use your finger, clean the tips, put it back again, and set it up to 0. Okay, that's your setting. And then you can go in and measure anything you want. Again, you can measure inside or anything from the outside. You can measure a diameter from the inside using these here. You can measure the depth of anything using the tail. And also you could measure the distance on a flat surface like we did before using the back. So this is another way of measuring from the back, from 0 to here. That will give you the size or the distance that we're talking about. Okay, I hope this is everything we have today, and I hope I summarized everything for you between metric and inches. I'm sure you're going to be using more of the metric. If you're working with jewelry, you're going to be using more metric than the inches, but you know both of them anyway. Get yourself a chart like this that will help you changing from inches into millimeter, and the conversion that will help. I hope every one of you already liked the video and learned something today. But if you have questions or if you need more information, please let me know. Just send me a message down below or a question, and I do answer every one that send me anything.